Okay, so we've got now a lecture, a video about something called the geocentric model. Geo means Earth, of course, centric, center. This is the old model that's really based on some ideas of Aristotle's. Remember him? And he placed the Earth in the middle of a cosmic system. They didn't call it the solar system. They might have called it something like universe, but they didn't call it the solar system. Nobody called it the solar system until we realized that the solar system was not the same as the universe. But the point here is that we've got all these observations. I'm not going to write them again. That would take up the whole board. 6 observations about the planets, and individual observations about the stars, the sun, and the moon. And we couldn't get out from below our atmosphere to see what's going on. We had no idea. We had to kind of figure out a model of the universe without leaving the Earth's surface. So all we had was this collection of observations, and there are more that I could add. The motions of the sun and of the moon, for example, are not as simple as I've made them out to be. The sun and moon both speed up and slow down in their daily run around, in their runs around the track. And there's a lot of other complicating factors as well. Remember, aside from the sun, none of them actually stay on the ecliptic. They're near the ecliptic, but they're not on it. So there's a lot of complicating factors, and the idea is to take all this wide array of observations and to render them comprehensible in terms of a single mental picture. That is, a model. And the first major model in Western history is a model that's based on Aristotle. And Aristotle had a few ideas about the way things should be. So Aristotle, 2nd, 3rd century BC, several hundred years before Christ walked the earth. Jesus walked the earth. Aristotle walked the earth. And he said, really for our money, 2 things that are really important. 1, the earth is motionless. Now, we know that's wrong. But what evidence do you have personally that it's wrong? What evidence do you have yourself that tells you that the earth is moving around the sun and rotating on its axis? You don't have any. The only evidence you only have 2 pieces of evidence, and they're both based on authority. One of them is probably your teacher told you it was true. Your 3rd or 4th grade teacher told you Earth goes around the sun. The other one is other authority is folks like NASA, right? And other representatives of the scientific and educational community. You've believed it because you were told it by people that you trust. And that's great, that's fine. A lot of us believe a lot of what we believe because people who we trust told us it was true. Okay? But if we always rely on that kind of knowledge, we'll probably not be real happy with our educations. The world might pass you by if you simply believe everything you're told by people that you trust. The world is more interesting than that. Okay? And so the point I'm trying to make here is that Aristotle said the earth is motionless, and that is an eminently reasonable axiom. That is assumption. That is starting point. Because no evidence of your senses, no reasoning, abstract reasoning, no argument you've ever come up with at all will tell you otherwise. All of your senses, okay, and every bit of experience you've ever had tells you that the earth is motionless. Okay? Except for maybe the occasional earthquake, which doesn't count. So, it's easy to sort of make fun of this, but the evidence is really strongly in favor of it. And also Aristotle's entire philosophical system was based on was all one system, and this was a major part of it, so it fit into a larger philosophical system. The second of Aristotle's axioms, axiom is just a it comes from mathematics, but it basically means fundamental fixed point that you start with, an assumption that you hold as you go forward. That is that all motion, all celestial motion, is uniform, and my pen's running out, uniform, how's that for a squeak? Uniform and circular. And when we say circular, we don't mean kind of circular, kind of round. He means circular, like mathematically, like precisely circular. Okay. So all celestial motion, by that I mean all motions of the stars, of the moon, of the planets, of the sun, all of those motions are not, the earth is not moving, so all those motions that we see are motions that those bodies are undergoing, and all those motions are circular and uniform. Uniform means neither slowing up nor neither slowing down or speeding up. Okay, that means a constant speed. That's what uniform means. You know what circular means. Uniform means constant speed. Neither slowing down nor speeding up. Okay? Those were Aristotle's two axioms. Earth is motionless, and all celestial motion of the sun, of the moon, of the stars, of the planets is uniform and circular. Okay? And so what he had in mind was a picture that looks something like this. All the stars were attached to our celestial sphere. Remember our celestial sphere from last week? All the stars were attached to it. The earth was in the center. And the earth did not rotate. It was the celestial sphere that rotates around that axis. Okay. And all the stars are attached to it. Okay? All the stars are attached to it. Oops. Like that. All right? So, this is how he had it. And so what he had to do was he had to imagine the Earth was in the middle, and then the moon's orbit was around that. Oops, this is not a good color. The moon's orbit, let's see, let's pick the orange will work. The moon's orbit was around the Earth, and then Mercury's orbit, was outside of that, and so forth and so on. So all the planets' orbits were inside of the celestial sphere, and so the planets went around on these orbits. Okay. But you can look at this and you can see that it's not possible to have the Earth fixed in the middle and have all the planets moving around it uniformly in circles and also have those planets back up. Right? You can't do that. Here's our planet. Here's the planet Mars, say. If the planet Mars has got to stay on its orbit and go uniformly in a circular motion, there's no way it can back up. Right? Retrograde motion is impossible. So it seems. Okay, there is a solution to this. This video is going to be a few minutes longer than average. So hang with me, maybe 16, 17 minutes. But there is a way to get around this. There is a way to have planets undergo uniform circular motion but still, from our perspective, seem to back up. And so what I'm going to do here is I'm going to erase this picture This is the overall picture of Aristotle's model, the geocentric model. But what Aristotle suggested, and others after him suggested, was something like this. Let's look down now at that same picture, but from above, so that the Earth is here. Okay, so that's the Earth. And here's the orbit of Mars around it. Okay? That's the orbit of Mars around the Earth. Well, Mars, again, cannot stay on this circle. It's not a good circle. In fact, I need to make myself happy. I need to move the Earth more towards the center. It's going to drive me crazy. If you ever want to draw a circle, don't draw the center of it first. Draw the center of it last. Draw the circle first and then the center. There you go. A little tip on drawing circles. So there's no way that Mars can stay on this circular orbit, neither speeding up nor slowing down, and also appear to back up every 2.1 years like it does in the sky. So what people came up with was this. This orbit here is actually known as a deferent. D-E-F-E-R-E-N-T. Deferent. And on top of that deferent, there was another circle. So this is circles on circles. Okay, I'm not making this up. This is really what they came up with. So there's another circle here. Okay. This circle is known as an epicycle. Not a unicycle, an epicycle. And that epicycle, the center of that epicycle, undergoes uniform circular motion around the deferent. Okay. And the planet Mars does not ride around on the deferent. It rides around on the epicycle. So there's Mars itself. Mars undergoes uniform circular motion. This is Mars, right? This is Earth. Mars undergoes uniform circular motion around the deferent, while the center of the deferent undergoes uniform circular motion. I'm sorry. Let me say that sentence again. Mars undergoes uniform circular motion around the epicycle. Mars undergoes uniform circular motion around the epicycle, while the center of the epicycle undergoes uniform circular motion around the deferent. And what that means is that if you follow the path of Mars, it will move forward for a little while, and as it moves in, it's going to back up as it reaches the inside of the epicycle, like a big spirograph deal. Like that. Okay? And so occasionally, from the Earth's point of view, Mars, this is its prograde motion, west to east. Occasionally, as it rides around the inside of the epicycle and gets closer to Earth, it's going to undergo a looping backwards motion before, this is retrograde, and retrograde here, and then it's going to go prograde again, and my pen is officially dying now. So it's going to undergo prograde motion, then retrograde, and then prograde for a while, then retrograde, and on and on. By tweaking the relative sizes of the epicycle and the deferent and the rate at which it goes around the epicycle, you can tweak this model to where the model matches and predicts pretty well what Mars does in the sky. And this was applied to all planets to some degree or the other. Epicycles and deferents. And over time, more constructions like this, one of them called the equant, one of them called the eccentric, were added to the model, so that by the time, by the time of 140 AD, a fellow named Ptolemy put together all the known astronomy of the ancient world into a book called the Almagest. Okay, it translates meaning the greatest. Put together a book called the Almagest, which had an entire system based on epicycles and other constructions like the eccentric and the equant, all these kind of strange to us looking wheels upon wheels. In fact, the moon there was an epicycle upon an epicycle for the moon. So an epicycle on top of this epicycle, and so forth and so on. And other weird geometric constructions that were used. There were actually 80 circles used by Ptolemy to describe the motions not only of Mars, but of Mercury and Venus and the moon and the sun and all the rest, with the Earth in the middle. And so to visualize this all at once is like some sort of crazy, merry-go-round sort of from hell. It's just all these different weird parts moving everywhere. But it worked. It worked for thousands of years. It worked. And this Ptolemy came around in 140 AD. For 1,300 years, his book, the Almagest, was the authoritative book on astronomy in the West. And it involved all these epicycles and deference. And again, before we sign off, we're at 16 minutes, I want to emphasize to you that this, as weird as it looks to us, right, epicycles don't exist. I'll give you the punchline. They don't exist. As weird as it looks to us, it worked. Okay, it worked. It described the predictions and motions of the planets very well for a long time. All right. We'll pick back up with the competing model due to our friend Nicholas Copernicus in video 16. See you then.